the earlier session on fluvial landform development, we have studied about the erosional landforms produced by the river. Rivers deposit sediments in different parts of the course and thus form various types of landforms. Such landforms are called as constructional landforms. Now we will try to understand about the formation of depositional landforms evolved by the river. In this session, we will try to focus on various aspects of fluvial depositional landform development, such as what are the major fluvial landforms, how and where these depositional landforms are formed, and what are their characteristics. The depositional landforms associated with the action of river are alluvial fans, alluvial cones, floodplains, point bars, meanders, oxbow lakes, braided river and deltas. Alluvial fans are formed when the river flowing in the mountainous stage or higher elevation descends into the foothill region or the plains. The river generally has a high velocity in the mountainous section of its course. Here it has a large capacity to erode and transport the rock fragments. Therefore, erosion is most important activity of a river in the upper course. However, as the river descends into the plain, its velocity declines and therefore there will be abrupt drop or decrease in the channel gradient, and consequently it starts depositing the load carried by it. The load becomes too heavy for the streams to carry over the gentler gradient. This material or the river load gets deposited in the zone at the foothills or the base of the mountains, forming fan-shaped depositional feature called as alluvial fan. The materials or the deposits spread in a semicircular form. The load of the river or the sediment consists of finer or coarser or big size material coming from the upstream areas and deposited at a point of break of the slope or the foot of the hill zone, and thus alluvial fans are formed. There is a sorting of deposits in the alluvial fans. The size of the sediment decreases outward from the apex, which is towards the foothills of the fan, towards their margins, which is called as distal side. Alluvial fans and alluvial cones are more or less same, except the difference in their gradients. Alluvial cones are formed when the slope of the hill or mountain front through which the stream descends into the steep. The formation of the alluvial cones requires more debris and less water. Many a times the alluvial fans increase in height by deposition of the sediments of the fans and their slope becomes steeper. Such cone-shaped deposits with a steeper slope formed at the foothill region is called as alluvial cones. Alluvial fans and alluvial cones are more or less similar, except the difference in their slope. Alluvial fans grow in height because of the gradual deposition of debris brought by the river. The gradual increase in the alluvial fan deposit increases the slope gradient. The slope of the alluvial fans are much gentler than those of alluvial cones. Alluvial cones are made up of coarser material when the alluvial fans Floodplains are one of the major landforms produced by river deposition. During the maturity stage of the river valleys become very broad and wider with a very gentler slope. Floodplains are an area located adjacent or on the either side of the river channel that is frequently inundated during the flooding of the river. When the river channel exceeds the carrying capacity of the water, the river overflows, leading to the flooding. When the river channel is full with water, the state of flow of river is known as bank full. During the flooding of the river, the load carried by the river spread out along both sides of the river, depositing thin sheets of sediments. The limit up to which the flood water reaches define the limit of the floodplain zone. The material that is deposited during the flooding of the river is called as floodplain deposits. Fine size material like sand, silt and clay are carried relatively slow moving water in the gentler channels, usually found in the floodplains. The floodplain often has areas of marsh and numerous lakes. Usually crescent-shaped lakes are found in the floodplains called as oxbow lakes. Floodplains are characterized by many distinctive features which include natural levees, back swamps, oxbow lakes and yazoo rivers. Natural levees are one of the important depositional form associated with floodplains. Natural levees are found along the banks of large rivers that are low linear parallel ridges along the coarse deposits along the banks of the river. Natural levees are ridge-like depositional features along the banks of the river. They are high near the banks of the river and slopes gently away from the river. The natural levees deposits are coarser than the deposits spread by the flood water away from the river. That is, the size of the deposits forming the natural levees is larger than the ones forming the floodplains. Levees are like small embankments and sand walls between the river and the floodplains. The low-lying floodplains adjoining the natural levees may contain marshy areas called as back swamps. These levees are usually about 1 to 2 meters high, but in some places they are much higher. The natural levees of the river Mississippi in USA and river 𝗲𝗏 in China are much higher. When the river breaks through the natural levees, a great devastation is caused. In the year 1852 and 1938, river 𝗲𝗏 breached the natural levees and caused devastating flood. River 𝗲𝗏 is called as Sorrow of China. A natural levee is a broad, low embankment built along the banks of the river channel during the floods. The place where tributary joins the main river forms a confluence. But when natural levees grow in height, the tributary stream will not be able to join the main river at its natural confluence. These streams run parallel to the main streams for several kilometers and join the main river. These streams are called as yazoo streams. Yazoo is a tributary to river Mississippi, which is a typical example of such streams. The new confluence is called as deferred junction. Point bars are also known as meander bars. Since these deposits occur on the point of the meander bend, they are called as point bar deposits. They are found on the concave side of the meanders of the large rivers and are sediments deposited in a linear fashion by the flowing rivers along the banks. They are almost uniform in profile and width and contain mixed size of sediments. If there is more than one ridge, narrow and elongated depressions are formed between 2 point bars. River builds series of them depending upon the water flow and supply of the sediments. As the river builds the point bars on the concave side, there will be erosion activity. During the mature stage of the river, as the river descends into the plains, its velocity is reduced due to the gentler slope in the valley. Due to lower velocity, the river has to go around and even minor obstructions in the path. The path of the river thus becomes serpentine or wavy. The tendency of the river to move along the serpentine path is called as meandering, and the curving bends in its course are called as meanders. The shape of the meander is usually semicircular. The river meanders refers to the bending in the longitudinal profile of the river. The bends of the Cynus River have been named meanders on the basis of meander river of Asia Minor in Turkey because it flows through numerous bends. Each bend of the meander belt has two types of valley sides. One side is characterized by concave slope, where the channel strikes the valley sides directly. With the result, the concave side is subjected to severe erosion, resulting in the formation of vertical cliffs. Lateral erosion of the banks leads to increase in the width of the river channel. The side of the meandering belt is also called as cliff slope. The other side of the meander belt is characterized by convex slope, which receives deposition mostly of sand, gravel and alluvial deposits. The convex side is characterized by gentle slope and is called as slip-off slope. Two most ideal conditions required for the development of the meanders are alluvial plains and gentle slope. Almost all the rivers in Indo-Gangetic plains of India have developed the meandering courses. The Ganga river has developed highly meandering course between Allahabad and Varanasi due to very low channel gradient. River 𝗂𝗏𝗓 in Uttar Pradesh is also a typical example of highly meandering river. Oxbow lakes are associated with the meandering river. The lakes formed due to the impounding of water in the abundant meander loop are called as oxbow lakes. They are the result of excessive meandering. Due to acute meandering, the areas of the flat terrain, the river water in the stream channel has a tendency to undertake lateral erosion. On one side of the river channel, the deposition on the other side. It is in due course, the two ends of the meandering loop come closer, or the neck of the meandering river becomes too constricted or narrower. When the curvature of the meander loop is accentuated due to lateral erosion, the meander loop becomes almost circular and the two ends of the meander loops comes closer, and ultimately the meander loop gets cut off from the main course of the river. After some time, the meander loop is completely abandoned and forms a crescentic shape or horseshoe shaped lake called as oxbow lake. Oxbow lakes are also called as moat lakes. In the process, the river straightens the course. The formation of the oxbow lakes owes to both lateral erosion and deposition. The meandering course of the river Ganga in Uttar Pradesh has its gradual southward shift or migration have left a series of oxbow lakes to the north of the present course of the river. The term braiding is the division of the stream into complex pattern of several small channels divided by the mid-channel bar. Due to lack of transporting capacity of the load, the river deposits the load in the mid of the channel to form an island. The coarser river deposits causing the formation of central bar which diverts the flow towards the bank, and this flow increases the lateral erosion on the banks. As the valley widens, the water column is reduced and more materials gets deposited as islands, and lateral sandy bars, which divides the flow of river water into several separate channels. Channels and the water flow is divided into multiple thin thread-like channels. These thin threads, like channel of water, rejoin and subdivide repeatedly to give typical braided pattern. Smaller elongated deposits are called as sandbars. Those which are larger and more extensive are called as islands. The Majoli Islands in the Brahmaputra river is a typical example of river island. It is among the largest river island in the world. A delta is a depositional feature or almost triangular shape formed at the mouth of the river before joining or entering a sea or a lake. When the river just before joining the sea, its velocity is reduced, so much so that it cannot transport even the finest particles of its load. Hence, the river undertakes deposition of load in this area. The widespread fan-shaped deposits near the mouth of the river is called as delta. These deposits obstruct the free flow of the main river, and hence the main river is divided into several channels or branches. These channels or branches are called as distributaries. The delta regions are areas of fertile soils. As the delta grows, the river distributaries continue to increase in length and the delta continues to build up into the sea. The deltaic deposits are well sorted with clear stratification. The coarsest deposits settle first and the finer deposits like silt and clays are carried into the sea. Deltas generally classified on the basis of shape, structure, size, growth, etc. The shape of the delta is determined by the physical conditions such as discharge of water, velocity of stream flow, supply and amount of sediments. Generally, delta's size and shape depend on the type and amount of deposited sediments and also on the power of waves and currents. In general, deltas are triangular in shape, but on the basis of shape, they may be divided into 4 basic types of deltas. Arcuate delta, that is fan shaped, bird's foot delta, which is also called as digitate delta, estuarine delta, cusped deltas. Arcuate deltas made of the coarser materials including sand, gravel and silt. Arcuate delta is an example of growing deltas. It grows towards the sea every year. The arcuate deltas are semicircular in shape. The middle portion of the delta has a maximum extent towards the sea. The delta in which the outermost margin exhibits an arc-like form and convex towards the sea is known as arcuate delta. Such deltas are formed when the river water is as dense as the sea water. The typical examples are the deltas of Nile, Ganges, Indus, Vango, Mekong, Irrawaddy, Rhine, etc. Bird's foot deltas. Bird's foot deltas resemble the shape of foot of a bird. The bird's foot delta is also called as digitate delta. They are formed due to the deposits of finer sediments. Sometimes these deltas, the sediment deposited, are composed of fine particles received from the limestone rock. These fine particles are also found to be dissolved in water. Due to these fine particles, the bottom of the deltas turn into non-porous. It has few long tributaries. These tributaries appear extended like the foot of the bird. This type of delta is formed when the power of the sea waves and currents is low. The distributaries of the main channel form linear segments of the delta and thus a linear delta is been formed. Mississippi Delta is the best example of bird's foot delta. Estuarine delta. This delta is formed from the materials deposited in the submerged mouth of the river, where the river enters into the sea through a single mouth or estuary. A long and narrow delta is formed. When the mouth of the river is submerged below the sea, narrow linear delta is been formed. The deltas of river Narbada, Tapi, Seine in France, Aube in USSR are examples of estuarine delta. Cusped delta. Cusped delta or the tooth-shaped delta is a symmetrical delta, usually formed when the river debouches straight coastline and in which the material is deposited evenly on the either side of the mouth. The delta of Tiber river in Italy is an example of the cusped delta. Whenever the velocity of the river is reduced, some of the load is deposited. Deposition is mostly confined to the middle and the lower course of the river, and therefore the depositional landforms are also seen in the middle and lower course of the rivers. As soon as the river leaves the mountainous stage, the depositional feature produced can be in the form of alluvial fans, alluvial cones. The depositional features associated with the floodplains include natural levees, point bars, river meanders, oxbow lakes, deferred junction, etc. The triangular depositional feature formed by the river before joining the sea is in the form of deltas. We are now familiar with the various fluvial landforms. In the next session, we will try to know about the concept of cycle of erosion and the cyclic evolution of fluvial or river landforms.